Hey, my name's Steve Demick. This is my presentation for data mining the U.S. statistics on aviation from the Department of Transportation. This is task number 2. Um, just like the task 1, the purpose is to mine this data and answer some interesting questions about it. So all the code's available on GitHub, and if you got any questions about code, because there was some issues on the grading where somebody said that it didn't use Cassandra. It did. And if you would have looked at the code just a little bit, you would have seen that it did, in fact, use Cassandra. So just please, if you have any questions like that type of thing, please look at the code. Also, if you just want to look at it, that's great too. System setup. Now, I misread this thing at the beginning. I didn't know you were supposed to have multiple nodes in there, so I have 2 this time. That's not great. I should have 3 to 5, but that's what I have. So they're the same type of system I had the previous time, the Hortonworks 2.1 sandbox. It's just what we use for cloud computing apps, the same type of deal. It's also got R installed on there, Cassandra, Apache Spark, Apache Kafka, and PySpark. Apache Spark ecosystem, you can see it's mostly used for streaming, also has Spark SQL. I had issues with Spark SQL, so didn't quite work for multiple when you had compound keys. Did not work for me. So Cassandra was much nicer, but the streaming part worked pretty well. If I had any issues with this thing, it was not with Spark. All right, so the general method for solving these problems fed the HDFS data into a Kafka producer, which fed into a Kafka server, and Apache Spark read from that, processed it with a Python script, output those to a Cassandra database, and I used an R script to do the final sorting, that type of thing, on the Cassandra. That's because CQL is horrible with the primary key only sorting on a primary key. That's just awful. I mean, for a database, you can't really have that. So, and then also can't do things like arithmetic for averages very well. So I used R for those type of things, and it worked out well. Okay, this is just a kind of a description of the components in the system, which, Kafka for message broker, Spark for streaming and real-time processing, PySpark, an implementation of the Spark programming model, Cassandra, NoSQL database, R, statistical programming language, Spark SQL, SQL interface for operating on RDDs. Little mention about the Spark programming model. It's built around resilient distributed data sets, or RDDs. Programming it involves a series of transformation on these RDDs. You end up pipelining together. It kind of really looks like Lisp to me. You do stuff like maps, filters, reduce by key, and sort by key, those type of things. Challenges here for me particularly was the Python Cassandra driver. I could not find one that worked. Turned out there was a bug in Cassandra between the different drivers. For the version of Cassandra that I had, did not work, which was very frustrating. I did not know at the time, but I tried the target holding one. I tried DataStax's PySpark driver, DataStax's Python driver, a couple of different JDBC drivers, and a different technique that was on a GitHub page that a lot of people looked for. Nothing worked. I compiled these locally. I brought them down from Git. I installed them locally. I did everything. Finally, an engineer from DataStax that was on a group email, he answered the question and found out there was an actual bug between Cassandra and the different drivers that involved the consistency level. So that was joyous. It took me at least 3 or 4 days to figure that out. Okay, another problem was performance. I didn't get this completely figured out, so I strongly suspect it's Kafka because the CPU usage is not that high. Yet the performance, it can take a long time. I mean, data's still coming out of there like 30 minutes after the thing is finished. So very small amounts of data, and the CPU's not high. The best thing I could do was try to move Cassandra to a different node. I mean, not Cassandra, but Kafka to a different node, but I was not able to do that in the time frame I had. I wish I could have. Or write my own custom Kafka producer. That probably would have done the trick as well, which I saw some people do. But I wasn't able to do that, so I got what I got, basically. which is poor performance. Also, the spark persist mechanism, man, that hit disk very heavily, and I was not happy with that. I think I had data loss on some of the problems, and I tie it to the spark persist in combination with the SQL. The Cassandra worked much nicer when I finally got that going. Conclusions, man, I had a hard time with it, but it was rewarding, and I learned a lot of stuff. So that's how it is, right? So a lot of times it's not completely successful, but man, I did learn a lot of stuff, and I enjoyed it. So here we go. Here's some demo. Okay, first thing I'm going to do is show you the different queries we were supposed to do on this. Let me just okay, so it uses R scripts to do the final kind of massaging of the data. But as you can see, I'll show you, the R doesn't do much. All right, so it reads the data via JDBC from Cassandra and does very simple things here, like from the deployer library. It mutates, it adds a column for average, and it arranges them. That's basically it. So really what you have here is it's Cassandra. And I'll run the different queries here so we can see what we got. All right, so okay, this is the problem 2.1, and this has to do with airports and carriers, the top 10 of carrier for each airport. We're going to run it, and we're going to get the data out for SRQ. I'm not sure. I think that's Syracuse. Okay, then we're going to CMH. I'm not sure where that is either, but we're going to get the top carriers for there. All right, then we got one I do know, JFK, top 10 carriers, top 10 carriers for Seattle, and top 10 carriers for Boston, finally. Next thing we're going to look at is top 10 destinations for each airport for departure delay. I'll take a look at that from Cassandra. And we are looking at SRQ again. All right, then CMH, JFK, Seattle, and Boston, finally. So for 2.3, it's for each origination destination pair, which are the top 10 carriers, and we're going to look at those. So for LaGuardia to Boston, you see the top 10 carriers. Notice how the first one there is that has the lowest average, but only has one flight. So you got to kind of watch out for that. So it's good to have both the totals and the average. Okay, Boston to LaGuardia, Oklahoma City to Dallas Fort Worth, Minneapolis St. Paul to Atlanta. Okay, now we're going to do the flight one, the Tom flying in 2 days in between, that one. Now my approach to this was to not just give a single answer, but to give options. Any option that fit, and then rank them by the delay. I thought that was an approach that was more similar to what you'd see on something like Orbitz than just giving a single answer. All right, so here we go. All right, so this is Boston to Atlanta, then 2 days later, Atlanta to LAX. Those are all the flights that meet those criteria. Okay, then Phoenix to JFK, and 2 days later, JFK to Minneapolis St. Paul. A very nice airport, by the way. All right, and we're going to take a look at the next one, which is Dallas Fort Worth to St. Louis. 2 days later, St. Louis to O'Hare. All right, and this one is LAX to Miami, and 2 days later, Miami back to LAX. Why you'd want to do that, I do not know. That's just a round trip, if you ask me. But, so that's how it kind of worked. I used R to do the final massaging because CQL is very primitive in those kind of things. You could do a select, I guess you could, but they didn't work for me because of the ordering issues. Okay, here I'm showing, this is my cluster. It's an anemic cluster, I admit. I wanted to add one more, but I was not able to get to that. But it is a cluster, and it's not like the first time around, and I misread that. The requirements are very weak in this. I would have had something better if I would have known that up front. I didn't really know it until I saw my grade from the paper that was graded for task 1, and then I said, oh wow, look at that. All right. Okay. So this is showing, let me show that these two things, this is the Cassandra node, this is the Spark node. They are indeed on different machines, all right, with different IP addresses. Okay, so over here we're just going to run, Cassandra, we're going to run CQL. All right, we're going to use. Be careful of doing that. Use my key space. All right, we're going to set up the query for O'Hare. That's a busy airport. Okay, so over here we got the Kafka server running. Over here we have the Spark running, a Java program. I mean a Python program. And down here we're gonna run our Kafka. Let's make sure we're in the right directory. And then we're going to cat all the airline data into it. Now here's where Kafka doesn't really perform very well. It takes a little while before it actually starts feeding data in, and like I said, it's got massive buffering problems. So I do believe the issues here are all related to Kafka, but it is what it is. I was able to do what I could do, and I can't do any more than that. So we're going to see. It takes a good, couple of minutes before it starts producing data, but it does. And here we go. We have data for O'Hare, and it's streaming in. Okay. Hasn't updated for a while. Alright. But you can see there is more data being added. It's just not for O'Hare at this particular time. Data coming in, it's trickling in. Like I said, the performance for Kafka is not the best. I was not as impressed with Kafka as the other pieces that I've learned about. So that's what it is. I'm not going to go through the whole thing. Like I said, this will take up to 30 minutes to do this whole thing. I know that's poor performance, the streaming, but I don't think it's the application's fault. I think it's Kafka's. So thanks a lot for listening. I did enjoy this, so thank you.